Hi, Assalamualaikum. In this video, we will continue with example 2 under the graph of polynomial functions. Okay, this is from previous semester papers. Consider the function f(x) equals to x times x minus 2 squared. Find number 1, the x-intercepts. Number 2, the interval where the function f(x) is increasing or decreasing. Hence, determine the extremum points. Number 3, find the interval where the function f(x) is concave up and concave down. Hence, determine the inflection point if any. And number 4, sketch the graph of f(x) using the above information. Alright. Now we start with number 1. Okay, find the x-intercept. Okay. So to find the x-intercept, we set when y equals to 0. Then we find the value of x. Okay. So when we set y equals to 0, y here means f(x). Okay. f(x) is x times x minus 2 squared. We equate to 0. Then we find the value of x. Okay. So when we equate to 0, we have x equals to 0 or x minus 2 equals to 0. So we have x equals to 0 and x equals to 2. Okay. So means that the x-intercepts are coordinate 0, 0 and coordinate 2, 0. Alright. And then number 2. Okay. Find the interval where the function is increasing or decreasing. Okay. So first, we can find the critical points. Okay. Because it can help us to find the extremum point. Okay. Alright. To find the critical point, first find f prime x. Okay. To find f prime x, we refer from f(x) equals to x times x minus 2 squared. Okay. Then we can expand, so we have x, we expand squared, so we have x squared minus 4x plus 4. Okay. And we have f(x) equals to x cubed minus 4x squared plus 4x. And after that, we can differentiate one by one with respect to x using sum and difference rule. So we differentiate f(x), so we have f prime x. And then differentiate x cubed, we have 3x squared. Differentiate negative 4x squared, we have negative 8. And differentiate positive 4x, we have positive 4. Okay. Alright, after that, when f prime x equals to 0, find the value of x. Okay. So from here, when f(x) equals to 0 means 3x squared minus 8x plus 4, we equate to 0. Then we solve the quadratic equation. Okay. Then we get x equals to 2 and x equals to 2 over 3. Right? And after that, to find the value of y, substitute the values of x obtained when we set f single prime equals to 0. Okay, and then we write into the form of coordinate. Okay, alright, so when x equals to 2, we substitute into f(x). Okay, f(x) means y. So we have y equals to 0. Okay. And then when x equals to 2 over 3, we substitute into f(x). So we have y equals to 32 over 27. Okay. Alright, so the critical points are coordinate 2, 0 and coordinate 2, 3, 32 over 27. Right? Alright, we continue with Roman 2. The interval where the function is increasing and decreasing. Okay. To find whether the function is increasing or decreasing, we can follow this step. Okay. First, find f prime x. Okay. In the previous slide, we done find f prime x. Okay. And then we need to equate f single prime equals to 0, and then we find the value of x. This step also done in the previous slide. Okay, then we can continue with table of sign for f single prime x. Okay, we use the values of x obtained when we equate f single prime x to 0. Okay, so this is the table with two values of x obtained in the previous slide. We have x equals to 2 over 3 and x equals to 2. Okay, and then we can write the interval for the left side of x equals to 2 over 3. We can write negative infinity to 2 over 3. Okay, and then between 2 over 3 and 2, we can write open interval 2 over 3, comma 2. Okay, this is not the coordinate, but this is between 2 over 3 and 2. Okay, and then for the right side of x equals to 2, we can write interval to infinity. Okay, and then test value. Okay, we can choose, let's say, 0, okay, which is satisfied in interval negative infinity to 2 over 3. Okay, in interval 2 over 3 to 2, we can choose, let's say, 1. Okay, and in interval to infinity, we can choose 10. Okay, that is satisfied in interval to infinity. Okay, alright, and then sign for f single prime x. Okay, from the previous slide, we have f single prime x equals to 3x squared minus 8x plus 4. So now, to find the sign here, we can substitute 0 into whatever x here. Okay, so after we substitute, we get positive 4. But we just need a sign, so we put positive sign here. Okay, and then we substitute 1 into f prime x here. So we get negative value, but we just put negative sign here. Okay, and then we substitute 10, okay, into whatever x in f prime x, and we get positive value. Okay, and then we can have slope or gradient based on the sign for f single prime x. Okay, alright, when f single prime x has positive value, okay, means we get increasing. Okay, and when f prime x has negative value, we get decreasing. Alright, so we can write increasing is from negative infinity to 2 over 3 and 2 to infinity. Okay, here. And then decreasing on 2 over 3, 2. Okay, this is interval. Okay, so this is increasing between 2 over 3 and 2. Right? Okay, and then after we find the increasing or decreasing, we can determine the extremum point. Extremum point means we need to state whether the extremum point is maximum or minimum. Okay. Alright. From critical points in the previous slide, okay, we get 2 over 3, 32 over 27, and 2 and coordinate to 0. Okay. If the graph change from increasing to decreasing, okay, from here to here, then we will get maximum. Okay. So the graph has maximum point at x equals to 2 over 3. Means the critical point 2 over 3, 32 over 27 is our maximum point. Right? And then if the graph change from decreasing to increasing, means we get minimum point. Okay, from here decreasing and then increasing, so we get minimum point at x equals to 2. Okay, from the critical point, okay, when x equals to 2, coordinate y equals to 0. Okay, so our minimum point equals to 0. Okay, maximum and minimum points come from the critical points. Okay, but the critical point we get before we use table of sign, and maximum and minimum point we get after we solve table of sign. Alright? Alright, number Roman 3. Find the interval where the function is concave up and concave down. Hence, determine the inflection point if any. Okay? Right, to find the concavity, we can refer these steps. Okay? Alright, first we need to find f double prime x. Okay? To find f double prime, we need to refer from f single prime x. Okay, we differentiate f single prime x, then we get second derivative or f double prime. Okay, when we differentiate f single prime x equals to 3x squared minus 8x plus 4, we will get 6x minus 8. Right? Then we equate f double prime x equals to 0 and find the values of x. Okay, so when f double prime x equals to 0, means 6x minus 8 will equals to 0. And then we solve this equation, so we get x equals to 4 over 3. Alright? And after that, use table of sign for f double prime x based on the values of x obtained when we equate f double prime equals to 0. Right? So, we continue with table of sign for f double prime x, okay, with x equals to 4 over 3. Okay, so for x equals to 4 over 3, from the left, the interval equals to open interval negative infinity to 4 over 3. Okay, and for the right side of x equals to 4 over 3, we can write open interval from 4 over 3 and infinity. Okay, and then we can test the value. Okay, for interval negative infinity to 4 over 3, we can choose 0 that satisfy in this interval. Okay, and then for interval 4 over 3 infinity, let's say we choose 10 because 10 satisfy in this interval. Okay, and then sign for f double prime x. Okay, when we substitute 0 into f double prime x, we get negative 8. But we just consider the sign. So means we can put negative sign here. Okay. And then substitute x equals to 10 into whatever x in f double prime. So we get positive value. But we just put positive sign here. Okay. Alright. So after we find the sign for f double prime, we can find the concavity. Okay. Alright. When f double prime has positive value, okay, means we can have concave up. Okay, concave up just like the graph looks like smile. Okay. And then when f double prime x has negative value, we get concave down. Okay, concave down looks like sad graph. Okay, when f double prime has negative value, we get sad graph or we get concave down. Right? Alright, so our concave up, okay, equals to interval 4 over 3 to infinity. Okay, and our concave down equals to interval negative infinity to 4 over 3. Okay. And after we find the concavity, we can determine the inflection point. Okay. To find the inflection point, if the graph change from concave down to concave up, means we have inflection point. Okay. Okay, now at x equals to 4 over 3, the concavity change, okay, from down to up. Okay. Alright, so if the concavity change from down to up or from up to down means we get an inflection point. Okay, so at 4/3, the concavity change. Okay, so means we have an inflection point here. Okay, so to find the point, we need to find coordinate y. So we substitute x equals to 4/3 into y or into fx. Okay, so our fx equals to x times x minus 2 squared. So we substitute x equals to 4/3. So we get y equals to 16/27. Okay, so our inflection point equals to coordinate 4/3, 16/27. Okay. Right, number 4, sketch the graph of fx using the above information. To sketch the graph of fx, we list down all the important points. The important points are maximum point, inflection point, and minimum point. Okay. We arrange based on ascending value of x. Okay. And then we draw y-axis, x-axis, origin, and we point out the coordinate of x. Okay. 2/3, and then 4/3, and 2. Okay. And we point out the coordinate of y. Okay. 0, 16/27, and 32/27. Then we point out coordinate of maximum point, 2/3, 32/27. Okay. And then we point out the coordinate of inflection. Okay. 4/3, 16/27. Okay. And we point out coordinate of minimum point to 0. And after that, we draw a small maximum curve. Okay. For maximum point 2/3, 32/27. Okay. Then we draw a small minimum curve. Okay. For coordinate to 0. Okay. And then we draw a small curve represent inflection. Okay. And after that, we join the graph. Okay. So this is the graph of fx equals to x times x minus 2 squared. Alright. And then we can check the x-intercept. Okay. From number 1, okay, we find coordinate of x-intercepts are 0, 0, and 2, 0. So let me check. Okay, this is coordinate of x-intercept. Okay, 0, 0, and 2, 0. And coordinate of y-intercept also 0, 0. 0, 0, which is origin, can be x-intercept and can be y-intercept. Okay, so this is the graph of fx equals to x times x minus 2 squared. Right? Coming up next, graph of rational functions. Thank you for watching. Stay tuned. Bye. Assalamualaikum.